thesis research centers around using an augmented reality sandbox. And basically, I'm using the sandbox to see if it impacts student learning in any way. So when you're moving the sand around, your topographic map that's digitally overlaid on the sand is moving around. So you can create like a hill per se, and you'd see the lines of elevation changing, the color changing as you increase in elevation. So, and it happens pretty quickly in real time.
We're interested in the sedimentation rates here in Upper Newport Bay. Upper Newport Bay is an estuary, which is one of the most biodiverse ecosystems in the world. And sedimentation rates are important to keep them preserved in the habitat. They provide habitat to over 10,000 migrating birds a year. And without these ecosystems, those birds won't have that habitat to feed and to rest on their migration routes.
As you know, modern walruses, they have a very distinct feature with their squish faces and the very long tusks. They're also very geographically restricted to the Arctic. We're finding through fossil walrus history, though, that wasn't the case. They not only had a variety of skull morphologies, but they also ranged all up and down the coast of the northern Pacific. So my research is going to be focusing on three different specimens.
There was an unidentified horse species that was found at the Mission Viejo Library, and so they asked us to come down and identify it. And so this is right here, if you notice, this is the skull. So we had the skull and we had one of the limbs, but we couldn't identify it until we actually had the lower jaw, which there's a mitigation company called LSA. They had it over there, so we were able to get the lower jaw and we were able to identify the species of horse, and we found out that it's the first recorded species of this kind of horse in Orange County.
My poster is on my environmental science master's project. I made a telescoping topography tool in ArcMap. So basically what that means is that we took LiDAR data from SHIFTS and NOAA, and you get LiDAR basically comes out kind of looking like this, and then you run these through different filter processes, and that actually allows it to get rid of like buildings or trees or whatever it is, the data that doesn't quite fit because it's not a true representation of what the ground level is. Eventually you can take that data and you can actually turn that into a digital elevation model or a raster image, and eventually that becomes contour data. This is particularly important because it really helps out with elevation, with just different models, causing weather patterns, or if you've got like a beachfront property or something like that, and suddenly you look out and your beachfront is now like a waterfront because all your beach is eroded away. Something like this can actually tell you maybe particularly what the cause of it is.
It's been going really well. I actually have another poster over there on oysters, so I kind of dabble in all paleontology, but I've been having a good time.
Research there has actually been pretty fun. I've been able to talk to a lot of people, both about my project and about their own projects. I feel like it's very worth coming to.
Research day's been going great. It's great to see everyone, presenting their research, showing what they're passionate about. Everyone's smiling, having a great time.